Hi, let's talk about mechanical advantage real quick. Mechanical advantage is a key thing to understand when we're talking about simple machines in our course. Mechanical advantage is a ratio of the forces, and the forces being our effort force and the resistance force. The actual mechanical advantage of a system can be found by dividing or finding the ratio of our resistance force divided by the effort force. For example, if you can lift 10 pounds with, let's say, 2 pounds of effort applied through the use of some machine, we have a mechanical advantage. How about we say an actual mechanical advantage of 5? Okay, because our FR, our resistance, would be the 10 pounds we're trying to lift. Our effort force is the 2 pounds. These are both pounds. And so we get a ratio of 5 to 1. May be written that way with a colon. Okay, so what does that mean? The mechanical advantage as a ratio over 1 helps us understand what kind of benefit that machine might do for us. So this helps me understand that 1 pound or 1 unit of force is going to result in or be able to match 5 pounds of resistance. So the machine is providing me an advantage with forces. Now there's a trade-off, and there's usually a trade-off with things. So while I'm getting an advantage with forces, there will be a trade-off that you'll see with all these simple machines that has to do with distance. So keep that in mind. A mechanical advantage of 5 to 1, I do have an advantage, but there's a trade-off. There's always a cost. Now while this mechanical advantage from that first example was 5, mechanical advantages do not have to be greater than 1. They could even be less than 1. What if you had a second example where, let's just say it took, we use the same 10 pounds, lift 10 pounds with 30 pounds of effort. The formula is still FR over FE. In this case, 10 is still our FR, 30 is now our FE, and so we would get a ratio of really 0.3. 10 thirds is a third, 0.3 or 0.3 to 1. Okay, oh, so I meant to note out before that the units for mechanical advantage is none. There's no units. The ratio, it's just a ratio because you're dividing common things, and so those units cancel out. Okay, so here we get a ratio of 0.3 as a decimal. 0.3 repeating, I guess. So what does that mean compared to our previous of 5? Well, in this case, it's taking more effort than the object itself. So it seems like a disadvantage. All right, well, we call it still mechanical advantage. The mechanical advantage, though, is a decimal of 0.3. It's less than 1. So while I don't really get a very good advantage when it comes to force, maybe that earlier trade-off we talked about distance somehow will factor in here. Let's look at one last quick thought. Example 3. What if it took 10 pounds with 10 pounds of force? So we could lift 10 pounds with 10 pounds of effort. If that was the case, again, FR over FE, we would get a ratio of 1 to 1. So our mechanical advantage, you can see here that if I'm lifting 10 pounds with 10 pounds of effort, it doesn't really feel like an advantage or a disadvantage. Okay, key things you need to know. Mechanical advantage equals to 1. There's no real benefit to the forces, but there's also no big cost or trade-off. If the mechanical advantage is less than 1, as that one was, I don't really have an advantage with forces. In fact, it's a disadvantage, right? It's going to take more effort than the resistance is itself. And if you have a mechanical advantage of greater than 1, as this one was, you will get an advantage when it comes to forces. 1 pound of effort resulted in 5 pounds of resistance. At least could overcome that. Okay, so be aware that mechanical advantage, it's never negative. It's going to be a positive value. 1 is that magic number in the middle where there's really no advantage or disadvantage. So this is kind of your special value. If mechanical advantage is equal to 1, no big change. If it's greater than 1, we get a benefit on the force, a trade-off on distance. And if we have a mechanical advantage less than 1, well, we have a disadvantage with forces, but maybe a benefit with distances. And I think this will all play out as we look at the simple machines that we are going to cover.